Greetings, all of my future mathematicians. We're going to take a look at our inside-out method again. Last time we looked at linear equations, and this time we're going to look at radical equations. I think you're going to find that it's not too much different, and that you're going to be just fine with this. And so, without further ado, the inside-out method for radical equations. The first thing I'll point out is that the steps are exactly the same. They're the ones we've been using for the past couple days. First, you break the problem down. Now you guys kind of know what that means, which is cool, because last time you were like, what in the world? Anyway, the second is don't opposite, do the opposite. And then our step 3 is to work backwards. You should already have this written down in your notes from the other day. If you happen to be someone who wasn't here for whatever reason, write these down really fast, give me a little wave, and I will pause so you can get it written down. But they are the exact same steps we wrote down during the Inside Out method video for working with linear equations. Okay, and so without further ado, since you guys are already a little bit more familiar with this, because I've been doing it for a few days, we're going to move forward and hopefully have more examples on this particular one than we did on the last one. So here we go. Okay, this part you do want to write down. This is new, okay? And this is something you need to know. We've already talked about how the opposite of addition is subtraction, and the opposite of multiplication is division, and vice versa. But we have not talked about radicals yet. Radicals means there's some kind of square root function. Okay, and square roots are something that we're going to go into a lot deeper later on in the semester. But here's what you need to know for this particular lesson, okay? You need to know that the opposite of a square root, which looks like this, okay, it's got no number up here in the corner. It's just this little thing. It kind of looks like a division symbol that has an extra little tail right there. That's a square root. The opposite of a square root is a square. And you'll notice that I have this little indication right here saying that that's an exponent. Okay, so you would have a number down here and raising it to the second power. Now just to make sure we remember what that is, when you're raising a number to the second power, you're not multiplying it by 2. You actually have 2 of those numbers and you multiply that together. So 5 squared would not be 5 times 2. It would be 2 5s. So it's 5 times 5, which is 25. So keep that in mind, and we will cover it a little bit more in this lesson a little bit later, okay? Also, the opposite of a cube root, it's a little bit different than the square root. The only difference is it has a little cube in the corner right there. It's got that 3, okay, is an exponent of 3. So the opposite of a square root is a square. The opposite of a cube root is a cube. If you think about it, it kind of makes sense. If you can remember the names, then you can remember what goes with what. Okay, and so believe it or not, that's the only thing we're adding to what we've already been doing. So some of you are going to pick this up like lightning fast, I swear. And then some of you might need a little bit more time, and as hopefully you already know, that is perfectly okay. Alright, so let's take a look now at our first example. Okay, our first example, and notice I kind of labeled it, okay, this is a square root function, and we're going to do some cube roots as well. So this is a square root function. Remember, it looks like a division sign with a tail. There's no number up here in the corner. Okay, so the way you say this is the square root, square root of 4x equals 16. Okay, square root of 4x equals 16. So this is how you are going to handle this. The first thing you're going to do is you're going to pretend that this 4x right here is kind of like in a parentheses. If it's sitting underneath a square root, that's just like having it in parentheses and raising it to a power or some other type of thing. So this is just like a parenthesis. So we're going to handle this first. As you already know with dealing with the inside-out method, we always start with our variable and we break our problem down. Our variable in this case happens to be x, and so we're going to start with an x. Well, what's happening to x? Remember I said pretend like that is in parentheses. So the first thing happening to x is it's being multiplied by 4. So we're going to put x times 4 to cover that, okay? So x times 4. Now, the next part's going to look a little bit funny, okay? But that's okay. Everything's kind of weird anyway in my class. And so it kind of just fits in with everything that we do. Okay, after we deal with everything that's beneath the square root, then we're just going to stick a square root symbol down here. So we have our x times 4, and that's where we take our square root, because that's what's the only thing that's under there is that 4x. And so then we're just going to put a little square root symbol. Remember, this is just us breaking the problem down, so we don't care if there's something underneath there. This is just triggering our memory as to, okay, well, at this point, I would take the square root based on my order of operations, okay? And then from here, it equals 16. So hopefully, so far, so good. You guys already know from our previous lesson our opposite for multiplying by 4. The opposite of multiplying by 4 is dividing by 4. Okay, so remember we broke the problem down. We said x is being multiplied by 4. Then we take the square root equals 16. X times 4 square root equals 16. Okay, now we're doing our opposites. We already did the one we know. The opposite of multiplying by 4 is dividing by 4. Now think back to what I told you at the beginning. What's the opposite of a square root? Okay. The opposite of a square root is a square. Alright? And then of course that's going to be equal to 16, but we don't have to write equal to 16 right now. So we did the breakdown of our equation. We did our we did our opposites. Now we have to go backwards. So I'm going to take this 16 right here, okay, and I'm going to put it backwards along this line. Now remember that this 2 right here, that's an exponent. So this is going to be 16 raised to the second power, or the other way to state that is 16 squared. And so 16 squared is, hold on, I'm typing it into my calculator and I was in the wrong place, is 256. So 16 squared is 256. Okay? And then, we're not done yet. We have to finish that last operation. 256 divided by 4 is 64. So our answer for this particular question, the square root of 4 times x equals 16, your correct answer is 64. Let me know, give me a little wave if you need me to pause this so you can write something down. If nothing else, I'm going to pause it anyway, but at least I can know if I'm pausing it specifically for you. So I'm going to pause in now. Okay, now that we have that settled, let's go ahead and move on to our next one. Each one of these is going to get just a little bit bigger, so we're going to have to really go back and use what we learned the other day, okay? The next one is the square root, so the square root of x plus 6 minus 4 equals 2. And so the most difficulty my students have with this particular type of question is figuring out whether you take that square root after x, after adding 6, or after subtracting 4. And here's the answer to that. Wherever the square root ends, that's where you take it. Okay, so let's take a look at what this looks like. First step, of course, is breaking our equation down. When we are breaking it down, the first thing we do is we always start with our variable. So our variable is x. So we have x, and then what's happening to x, we have x plus 6. So x plus 6 And then notice, that's where the square root ends, okay? X plus 6, and then our square root. So we'll take our square root right there, okay? So x plus 6, that's the end of our square root, so we take our square root, then minus 4 equals 2. Okay? So there's our step 1. We have broken down the equation. Now, step 2, don't opposite, do the opposite. And so that's exactly what we're going to do. The opposite of subtraction, I'm going to start from the right and go left. Okay, so I'm going to start over here and go this way for those of you that are solving along with me. The opposite of subtracting 4 is adding 4. The opposite of taking the square root is squaring it. Notice how I put it little and high so I can tell that it's an exponent, okay? And the opposite of adding 6 is subtracting 6. So I did my first step. I broke the equation down. X plus 6, take our square root there, minus 4 equals 2. Then I found my opposites. The opposite of subtracting 4 is adding 4. The opposite of a square root is a square. The opposite of adding 6 is subtracting 6. Our third step is going backwards. We take our 2 and we go backwards along this line. Okay? So 2 plus 4 is 6. Okay? 2 plus 4 is 6. 6, remember this is not times 2, that's 6 squared. 6 squared means you have 6 times 6. Alright? And 6 times 6 is 36. And we still have another step. 36 minus 6 is 30. So there's our answer. We've got nothing left over here. We finished everything. And so we just write it down and circle it. So x is equal to 30. Hopefully, so far so good. I'm going to start speeding these up just a little bit because we've been doing them so much. If you need me to slow them down in the classroom, or if you need me to explain them again, I absolutely will. Okay? Also, if you would like me to pause at the beginning of a question so you guys can try it on your own, and then I'll press play, also let me know if you'd like that, because that, again, is totally okay. Alright? So let's move on to our next question. All right, we've got question number 3, and it looks like this. We have the square root of x minus 4. Notice how that's all beneath our square root, okay? Divided by 3 equals 1. You could also put this, sometimes instead of saying the word square root, they'll just say the word root. And so this would also be stated as root x minus 4 over 3. So that's another way you could state it. Honestly, it doesn't matter which way you choose. So our first step, I told you I was going to move a little faster. I wasn't kidding. I'm going to, okay? My first step, I always start with x when I'm breaking down my equation. So I have x, and then I have minus 4 because that's still beneath the square root. That's the end of my square root sign, so I'm going to go ahead and take my square root right there. So I have, so far, x minus 4, and then take the square root, and then we have over 3. Now don't forget back to what I taught you. Anytime you have a fraction, that just means division. So we're going to divide by 3, and then that is equal to 1. So our first step is finished. Our second step, don't opposite, do the opposite. The opposite of dividing by 3 is multiplying by 3. The opposite of taking the square root is squaring it. The opposite of subtracting 4 is adding 4. And then we're just going to take our number at the end and just go along this line for our step 3. So step 1, break it down. Step 2, do the opposite. Step 3, go backwards. We have 1 times 3, which is 3. 3 squared is 9, and 9 plus 4 is 13. And so far, so good, I hope. That is exactly what we are looking for here. Okay? And so, just for fun, we're going to take a momentary corny joke break, okay? I try to do this sometimes when we've got some really heavily packed curriculum. We've been doing this for several days, and so here is our corny joke day, all right? Well, not day, but our corny joke moment. Okay, the question is, why do ghosts love elevators? Do you know? No? Okay, well, I will tell you. Ghosts love elevators because they lift their spirits. Yeah? Maybe? No? Okay, you're probably not the only one who thinks that joke is bad. It admittedly is pretty bad. And so we'll just move past that and pretend it never happened, okay? Let's take a look at number 4. This one is a bit more spread out. You've got more things going on. And so let's see what we can do with this, okay? As always, we start with x. And so we're going to start with x, which of course is right here. So just so we can kind of center ourselves in this crazy mess over here. So we have x. The first thing happening to x, remember we treat the square root as if it's a parenthesis. So that 3x plus 2 is going to come first, okay? First thing that's happening is that x is being multiplied by 3. So x times 3, and then we add 2. So plus 2. That's the end of our square root. And so we're going to take our square root right there, okay? And then on the outside of this crazy thing, we've got another 2. So here's what you do with that. Just as if this were a parentheses, okay? And remember I told you if it's hugging, then it's multiplying. Well, guess what? This 2 is hugging that square root sign. So that means we are multiplying by 2. So times 2, okay? Then we can't forget to go jump over here to the other side. This is the only thing we haven't dealt with yet. So after multiplying by 2 over here, we jump over here. We're going to subtract 4. So minus 4 equals 6. Ooh, running out of room there. Okay. So now we broke down the equation. That's our step 1. Step 2, don't opposite, do the opposite. And so let's go on through here. I think we're getting good at these, I hope. Okay? The opposite of subtracting 4 is adding 4. The opposite of multiplying by 2 is dividing by 2. The opposite of taking the square root is taking the square. The opposite of adding 2 is subtracting 2. And the opposite of multiplying by 3 is dividing by 3. This is kind of a monster of a problem, but you guys are going to see, just like always, 3 steps, okay? We broke the problem down, we've done our opposites, and now we're going to go backwards and work through these. Okay, so here we go. We start with 6. 6 plus 4 is 10, okay? 10 divided by 2 is 5. 5, jump up to that exponent. 5 squared is 25. Okay, so 5 squared is 25. Remember, whenever you square something, you're taking that same number, and it's that same number twice. So it's 5 times 5, which is 25. Okay, 25 minus 2 is 23. Now this one's going to come out to be a decimal, but I left it here because you need to see that, okay? And then 23 divided by 3. If you plug that into the calculator, it's going to give you 7.6666666666667. So essentially what's happening is the only reason they round it to the 7 at the end is because they've run out of numbers and they've run out of room. We're not going to round it. So 23 divided by 3 is 7 followed by tons of 6s. Instead of filling up our page with 6s, we denote that with what's called a repeating sign. So 23 divided by 3 is 7.6, and then you put a line over the 6 to say that 6 just keeps repeating. So that's what that means, okay? So 7.6 repeating. And essentially it's a little bit over 7.5. All right? Awesome possum. That is actually it for our square roots. We're going to look at 2 more examples, and both of them are going to have cube roots, okay? But remember, it's not much different. It's just instead of doing your square root and then square, you're going to have a cube root and you're going to have a raised to the 3rd power. So it's going to be okay. All right? Breathe. Don't panic. Here we go. The cube root of 2x minus 4 equals 2. Guess what, guys? It looks hard, but it is the exact same 3 steps. We start with our variable, x. We find out what is happening to it. X is being multiplied by 2, and we're subtracting 4. Multiplication comes before subtraction in the order of operations, so we're going to put it first now. X times 2, okay, and then minus 4. That's the end of our cube root, so that is where we are going to take our cube root. It doesn't have to be big, it doesn't have to be fancy, it doesn't even have to be pretty. It just has to remind us that right there, that's where we take our cube root, okay? And that is all equal to 2. We've broken it down. Now we do the opposites, okay? The opposite of the square root of 3 is cubed. Do y'all remember that? We wrote it down at the very beginning. The opposite of the square root of 3 is cubing something, okay? The opposite of subtracting 4 is adding 4, and the opposite of multiplying by 2 is dividing by 2. Now we take this and we go backwards. I'm going to kind of show you what this cube thing means, okay? I explained the other one verbally, but this is what 2 cubed means. And I'm going to pick a different color so y'all can tell the difference. I'm going to pick green. Okay, 2 cubed, or 2 to the 3rd power, means that you've got 3 2's, and they're all being multiplied, okay? And so it's 2 cubed is 2 times 2 times 2. It is not 6, okay? 2 times 2 is 4, times 2 again is 8. So 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. 8 plus 4 is 12. 12 divided by 2 is 6. Okay? And so that's it. Big, huge, long problem. Just getting it done, getting it moving, getting it pushed forward. Okay? We've got one more example, just one, and then we're going to be done today, alright? Remember, if you need help, there's 2 ways to get my attention. You either raise your hand and say pause if you want me to pause the video and address the entire class, or you just raise your hand and I'll come over and I'll talk to you individually, okay? Last question, probably the hardest one, but that's okay. I'll work with it and I'll work with you, okay? Our variable this time is way on the opposite side, but we still start with it, okay? C. So C. What's happening to it? It's being multiplied by 6. It's a positive 6. So, because that plus sign means that it's positive. It goes with the 6. It's a positive 6. So C times 6. C times 6. And then we've got this negative 2 out here. Something some of you have been struggling with is realizing what's different, negative or minus. Here's what I'm going to tell you. If it's negative, it's probably a minus. It means pretty much the same thing most of the time. There are a few occasions when it means something different, but it always means that we're decreasing something. If we're going in a negative direction, we're getting smaller. And so we're going to have c times 6 and then minus 2. Okay? At that point, we take our cube root, because that's the end of our little cube root function. We have our negative, or our, I'm sorry, not our negative 3. We are dividing by 3 because it's in the denominator. Remember, fraction means divide. So we're going to divide by 3 and then equals 2. We broke it down. Second step, don't opposite, do the opposite. And so let's go ahead and go through there. I'm going to start from the right and go left. The opposite of dividing by 3 is going to be multiplying by 3. The opposite of taking the cube root is raising it to the third power or cubing the number. The opposite of subtracting 2 is adding 2. And the opposite of multiplying by 6 is dividing by 6. Okay? So we've broken it down. We have done our opposites, and now we are going to go backwards. Alright, so here we go. 2 times 3 is 6. Okay? Now, 6 raised to the third power. Remember, that's not 6 times 3. It's 6 times 6 times 6. So 6 raised to the third power, or 6 cubed, is 216. Okay? Now we just keep going. 216 plus 2 is 218. Okay? We just added 2 on top of it. Big numbers, but we don't care. Alright? And then 218 divided by 6. Okay? It's not going to come out even, but we can do the same thing we did a little bit ago. Okay? It ends up being 36.333333. So we are going to put 36.3 repeating. And then we're just going to circle it. And we are done. Just symbolize we're done. Look. Yay! I did it ahead of time. You guys, I'm going to turn it back over to myself in the classroom. Ironic, I know, but it'll work out. And we'll finish up the lesson there, okay? Great job. I hope you understand. If you didn't, I hope you ask questions. And I will talk to you later. Bye.